Alright, so today we're going to integrate trig functions, inverse trig functions, but we're going to start off just with a reminder of what the derivative of arcsine is. That's another way to write arcsine. So let's see if you've memorized that in between these notes. So hopefully you remember that all of them have du in the numerator. And then in the denominator, sine is the first one of the three that we would think of. And so remember, two of them have the square root. Tangent does not have the square root. So we have the square root, and then since sine comes first, 1 minus u squared. Okay, so they all have du in the numerator. They have square roots in the denominator except for tangent and cotangent. And since sine comes first, we put the 1 there. And if you remember, secant, these are flipped around and there's an extra absolute value of u there. And tangent is 1 plus u squared. So if you think about the derivative of arc cosine, hopefully you remember that that is just the opposite, so it's negative. And there's your magic 5. You need to get a little magic for a day. There you go. Okay, so for integrals, we're just looking for that same pattern. So we're looking for something down here where we want to identify u and a. Now you may say, well, there was no a up here. Well, the ones we did, a was equal to 1. So it fit that pattern. So when we did that assignment, they chose problems that fit that pattern. They didn't want to complicate it with the addition of the different value of a here. So going backwards, recognizing this formula in reverse, we just want to make an adjustment for whatever a is, divide by a. Tangent, we talked about tangent does not have the square root, and it's plus. And notice how we get the additional 1 over a out in front of tangent. Okay. And also with secant, arctangent, arcsecant, we get that extra 1 over a out in front as well. So we're just going to, so this is highlighted. Usually they don't have a derivative and an integral for inverse trig function. Usually they have one or the other. So this is not something we want to go overboard on because it's not a big part of the AP test, but if you memorize the formulas, it's definitely some points we could pick up. So what we want to kind of do here is identify, okay, a squared is 4, so a is 2. So we're just trying to identify a couple of these things. So u squared is x squared in this case, so u is x and du is dx. Okay, so if we substitute into that, the dx is du, and down here we're going to have 2 squared minus u squared. And now that we have that, we can go back and use the formula. So the formula, when we have this situation, is the arcsine, or the inverse sine, of this, which is going to be x over a, which is 2, and then plus c, and that's it. Alright. Now you want to be careful because your first thought here is that this is going to be tangent, and it certainly might be tangent, but there are cases where we may have to make an adjustment and it might not come out to be tangent. But that's what should be the first thing on our mind. So just like on this last one, what we're trying to do is rewrite these so they fit one of these patterns, but we kind of need to have these patterns memorized. I know you just started looking at this, but so the thing we would try here probably is let's let a squared be 2 and square root both sides. So a is going to be root 2. And then over here, let's let u squared be 9x squared. So u is going to be 3x. and du is going to be 3 dx. Now there is no 3 dx, so we're going to need to divide by 3 there. So now if we rewrite this, dx is going to become 1/3 du, so we'll put the 1/3 out there. There's going to be a du in here. We can just put that in the numerator, du. And then down here we're going to have root 2 squared plus 3, we switch that to u. We end up switching it back at the end, but still. Alright, so that's going to be u squared. Okay, so now this gets a little bit tricky. So, I mean, I don't think I'm not even sure I have that memorized yet, but 1/3, and remember that's tangent is 1/a. It starts with 1/a, and secant has that also. So a is root 2, so that's going to be that, and then it's arctan. Could have written arctan to mix it up a little bit. Maybe I'll do arc on that one. And then it's u/a. I think I'm going to double check u/a. So u is 3x, so that's going to be 3x/a, which is root 2 plus c. So 1/a plus we had the 1/3 there, so that's 1/a, that's good. Inverse tangent u/a. Alright, so that's good. Hopefully I'll remember to do arctangent on this last one. So let's see here. So this one is flipped over. So u, I guess I could start with u squared. U squared is 4x squared. So u is 2x. du is 2 dx. Okay. Now this gets a little bit tricky. A squared is 9, so a is 3. Okay, so we go to integrate this, and we're trying to do a little rewrite here. And remember, we want the absolute value of u out here. So u is 2x. So we want this to be 2x. So this is a little bit, and also we want 2 dx. So we want 2 dx, and we also want this to be 2x. Well, that's pretty convenient because 2/2 is 1. So we can multiply this by 2/2. That'll give us the 2 with the dx that we want. It'll also give us the 2 with the x to be able to replace that with u. So now I'm trying to think if there's a different way to do that, but I'm just going to leave it like that. So now that's going to become du. This is going to become u, and this is going to be u squared minus 3 squared. Probably didn't need a parenthesis around either one of those, maybe, but okay. So now that is 1/a, so a was 3. So that's going to be 1/3. And I'm just going to write this as arcsecant just so we remember that it could be arcsecant. And then it is the absolute value of u, which is 2x, over a, which was 3. Okay. So if it is on the AP test, it'll be pretty straightforward. Like I said, it'll either be a derivative or an integral, most likely. Okay. So moving along, we run into this down here. Now, we have if we're going to let u squared be e to the 2x, if we square root both sides, that's just going to be e to the x. Right, if we square this, we get that. So if we square root it, we get that. And here, a equals 1, so that's going to simplify some things a little bit. Now, if we do du here, du equals, the derivative of e to the x is e to the x dx. Okay. So that's a little bit awkward. So we don't want, there's no extra e to the x, so we need to take that over here. So now we know that dx equals this, but that's also awkward because we don't want an x with the u's. However, if we look at that right there, then we can say, oh, well, du over u equals dx. Okay, so you say, well, how do you know to do that? Well, we know that we want dx, and dx is by itself up here, so we get dx by itself, and then when we get to this stage, we realize, well, we don't want a u and an x, so we look back up here hoping, oh, hey, we can switch that out. Okay, so now, if we rewrite this, that dx is going to become du over u, and this is going to be u squared minus 1 squared, which is just 1. Now I'm going to still fill in the pattern even though a equals 1, just so that we're trying to memorize that pattern. So hopefully this kind of clues you in that we're dealing with secant. So because of this and because it's minus 1, if it's sine, it's 1 minus u squared, 1 squared minus u squared. Okay, so 1 over a was 1. So it starts off with 1 over a. I'm going to, since I have an arc secant up there, I'll do a inverse secant right here. And then it's the absolute value of u, so that's the absolute value of e to the x. I went ahead and switched it already back. And that's over a, but again, that's just 1. So we normally wouldn't, you wouldn't write that in your work. This is just the notes kind of demonstrating. And then plus c. So that's just inverse secant of e to the x. And actually, e to the x is always positive. So we could drop that off. Alright. So this is a 2-pager, so we're, I'd say a little bit more than halfway done maybe, except these 3 problems might be a little bit longer, but let's see how that goes. Alright, so now we can really see if we remember them because they're on the other side. So when you look at this, hopefully you think to yourself, well, I mean, obviously there's a reason I have that highlighted. Okay, so that's, even though it looks like there's stuff in there, it's still just one term. It's all together. So it's a single term denominator. So I've gone over that many times, trying to start to get you to think about what that means. So that means we want to split this. Okay, so we're going to have the integral of x over, and maybe we will, I guess I'll do this, and then plus 2 over that. Now, dx and dx. Okay. So the question kind of becomes, well, what are we going to use here? So I'll just tell you right now, one of these is a inverse trig function, and one of them we can just use our normal rules on. So, excuse me. Let's think about this for a second. Here, I can just use normal u substitution, because if I let u be 4 minus x squared, because that's inside there, and then du would be negative 2x dx. Well, I have x dx right there, so I could divide by negative 2 on both sides, and that'll cancel this out, and there's my x dx right there. So now I can rewrite that as negative 1/2, and then this is du, but this is u to the 1/2 underneath here, which I could rewrite as u to the negative 1/2. Okay. So now, I'm just going to go ahead and integrate this now. So if I add 1 to the exponent, that would be 1/2, and divide by the new exponent. So dividing by 1/2 is like multiplying by 2. I don't know if maybe I should write that out. So times 2, dividing by the new exponent. Yeah. So that's going to be negative square root of u, which was 4 minus x squared. Now, there would be a plus c here, and then there would be a plus c over here. I guess I can do that. Plus c1. Okay. Now, when we move over here, we can't do the same thing. You say, well, let's let u equal this. But the problem is we don't have that extra x up there, so we're not going to get a nice situation with our du. So here's where we want to realize that this, and both of these look like they could be inverse trig integrals, but because we were able to use u substitution on that one, it's not. So one of the things I can do here is we can do here is factor out that 2 and get it out of the way. Now if you look at this, that's going to tell you that a squared equals 4, so a equals 2. U squared equals x squared, so u equals x, so du equals dx. Okay, so we had that factored out, the 2, and then the dx becomes du, and then here we have the square root of 2 squared minus u squared, and that's going to fit our arc sign, inverse sign. So that's going to be inverse sine. Now remember, sine, we don't have to have the 1 over a in front. So we don't have that extra 1/2. Only sine. The other two, we both have 1 over a in front. And then u goes in the numerator, so u is just x. And it goes over a. A was 2. And then we would have a plus c2 with that. And then we can combine those two. And we would just have a new constant there. Okay, so probably not all of that on an AB Calc test, because you see it kind of takes a long time. Probably wouldn't have this both. This would probably be 2 separate questions if they were going to ask something like this, maybe. Or if they do have you separated, it'll be something that you can solve more quickly. Okay. Completing the square. So, what happens here is that you can't use u substitution, because if we take the derivative of this, we get 2x minus 4. There's nothing really that's going to happen there. But what we can do is, because we have a trinomial down here, we could complete the square on that and create that kind of u squared and a squared situation. Okay, so I don't know if you want to write a note. We can't use u substitution, so we need to try something. So let's see, if we let b equal negative 4, and we take half of b, which is negative 2, and then we take half of b squared, which is 4. We're doing the completing the square process. So you have x squared minus 4x that you separate into a trinomial, and then you move the plus 7 over here. Okay? So maybe I should have done that first, and then what I do is I look at b, take half of that, and square that. So once we've squared that, we are going to add that to both sides. Now, actually, both sides, if there was an equal sign and we were doing something a little bit different here, we would add 4 to both sides. But this is an expression. And since we have an expression and we just added 4 to it, we changed the value of it. So we need to keep the value the same. So to nullify the adding 4, we need to subtract 4 over here. Okay, instead of adding 4, there's no both sides. To have both sides, you need to have an equal sign. So it's all just one thing. So hopefully you see the plus 4 and the minus 4 is 0. So we really didn't change the value of this whole thing here. Now if you were multiplying by a number in front here, you would have to multiply it and take care of that, but they're not going to have anything like that. So now this factors to whatever you had in the middle right here. So whatever this was, that's what we're going to have right here. So there's the minus 2 right there. And that's going to be squared, and then this will be plus 3. So that was the whole point in doing that. So now, if we imagine that this is x minus 2 squared plus 3, now we can say that u is x minus 2 and du is dx. And I could have said u squared equals that, started off if you wanted to, and you could say a squared equals 3. So a equals root 3. Okay, so if we break that up using our values here, we would have du, and then down here, this would be u squared and plus root 3 squared. So hopefully you know what that is. That is, there's no square roots. So that's tangent, arctangent. So that starts off with 1 over a. And I'm probably going a little too fast here. You should probably be pausing this and trying to do something yourself. But tangent, does tangent have an absolute value? I don't remember. No, it doesn't. Just secant. So tangent, u was x minus 2, so we're going to have x minus 2 over root 3 plus c. Alright, we're jamming right along here. We're almost done. We just have one left. And so here, let's see what I want to use there. I'll use green. So we see the area of the region. So as soon as you see that, that should tell you that you're doing an integral. Area integral. So this is going from 3 over 2 to 9 over 4. So I'll put those up there. And then we have that function. So that function is going to be, I'm going to go ahead and put dx over the square root of 3x minus x squared. Okay, now, let's see here. We can't use u substitution because the du is not going to match up with what we have out here. Maybe we could find another way to do that, but it would probably get pretty messy. So my next thought is, especially because it's in this lesson, is maybe I can get that to be one of the inverse trig functions, which means I would need to again complete the square. So this one's a little bit trickier. So if we come over here, what I would need to do is factor out a negative. So that would be x squared, and then if I factor negative that would be minus 3x. And then I would have this, and that's it so far. Okay? So now this gets a little bit tricky. So we could say, what's b? So b is negative 3. And what would half of b be? That would be negative 3 over 2. And then what's half of b squared? Well, that would be 9/4. Alright. I didn't really leave myself enough room here for what I'm going to need to do. But so I'm going to add 9/4 in here, but then what I would do back when I was teaching Algebra 2 is I would say, what did we really add? What did we really add if we added a 9/4 in there? Actually, we added a negative 9/4. So how do I cancel out negative 9/4? I need to add 9/4. Negative 9/4 plus 9/4 is 0, which would get us back to where we need it to be. Okay, now we're going to factor that, and that's going to be x, and remember it's whatever this is, so it's going to be x minus 3/2 squared. Now what we can do with that is we can move that 9/4 in front right here. Okay. And now if you think about that, so a squared is 9/4, so a is 3/2, and here we have u squared equals all of that stuff, x minus 3/2 squared. So u equals x minus 3/2, and du equals dx. So now we can come back over here and we can switch this. Now, because I have these, I'm going to leave it in terms of x. So this is going to be dx, and this is going to be the square root of 3/2, instead of putting a in there, 3/2 squared minus x minus 3/2 squared. Okay, so this is our kind of our one value here, where it's 1 minus x squared. So this is sine. So we have arc sine, inverse sine, and then it's u, which is x minus 3/2, over a, which is 3/2. Remember, there's no 1 over a in front of sine. That's the only sine and cosine. That's the only one. And there's no plus c because we have these this a definite integral. All right. So the next thing I would do with this is it's a complex fraction, so I would multiply by 2 over 2. Okay. So now the other thing I would do, that's 2x minus 3 over 3. I better not skip any steps here. Alright, so that's going to be 2x minus 3 over 3. Same. Then what we could do is separate that because there's a single term there. So that's going to be 2/3 x minus 1. Okay, so now if we plug these values in, we're going to have the inverse sine. If we plug 9/4 in there, we get 9 over 3 is 3, and then the 2 and the 4 reduce 2, so we get 3/2 minus 1, so that's going to be 1/2. And then when we plug in 3/2, that's just 0. Because 3/2 times 2/3 is 1, 1 minus 1 is 0. Okay, so in the domain of this, sine is 1/2. So when sine is 1/2, that's the y value, and 1/2 is the short number, so that means it's going to be a small angle. This will be 30 degrees, which is pi over 6, and this is 0. So The answer to that is pi over 6. And it's about that time. Have a good day.